Here we have an ellipse with center and coordinates h, comma, k. And to generate an ellipse, what we need to do is this. First, pick any two foci. So pick any two numbers, 2 points, horizontally like this, any 2 points. And then, so in this particular case, we picked the points negative 10, 0 and 10, 0. And so the distance between here and the first focus and the second focus, the distance between them is 20. So pick any two foci that are horizontally aligned. And then next, pick a number, a constant that's greater than the distance from F1, from focus 1 to focus 2. And so for this particular example, we picked the number 24. And the distance from here to here is 20. And our constant, we call it d, is 24. To get the points on the ellipse, then the distance from this point A to the focus to this focus plus the distance from point A to this focus is equal to 24. And this point, the distance from point C to focus 2 plus distance from point C to focus 1 is 24. The distance from point E to focus 2 plus the distance from point E to focus 1 is 24. And so in summary, any point that's on this ellipse, the distance from the point to the first focus plus the distance from the point to the second focus must be 24. And so we can see that for a different constant, then we get a different ellipse. And the points that are at these two ends, this is called vertex number 1. This is called vertex number 2. And the distance from here to here, we call this the major axis. So the major axis is from vertex 1 to vertex 2. And we can see that the major vertex is parallel to the x-axis. And when the major axis is parallel to the x-axis, and when we worked it out, the equation comes out to be like this. And the distance from here to here, from M1 to M2, we call that the minor axis. And then the H, the K here, that's the center of the ellipse. The A is the distance from center to vertex. The B, that's the distance from center to M1. And then C is the distance from center to focus. And the relationship between A, B, C is going to be B squared plus C squared equal to A squared, where A squared is the longest length. So A squared, A to be the distance from the center to the vertex, and it would be longer than the distance from the center to the focus, or the center to M1. The vertices, this vertex right here, it will locate at H minus A, comma K, and H plus, so this will be H minus A, comma K. And this point will be H plus A, comma K. The two foci, this one will be H minus C, comma K, and this one will be H plus C, comma K. And the other type of ellipse is where the major axis, one more time, the major axis is from vertex 1 to vertex 2. That's called the major axis. If the major axis is parallel to the y-axis, then we get this set of equations. And same thing here, if we pick any point on the ellipse, then the distance from the point, so let's say we pick this point, the distance from point G to focus 1 plus the distance from point G to focus 2. Those two distances must equal to 24, since we picked a constant of 24. If we picked a constant of, let's say, 20, then we get a different ellipse. and the equation will be x minus h squared, and then plus y minus k squared divided by h squared. And so the question becomes, what's the difference between this equation and the other equation? A is the distance from the center to the vertex. So A will always be longer than C, which is the distance from center to focus, and B is the distance from center to either M1 or M2. So for ABC, A is always going to be the longest. And so if A squared is under the x minus h squared, then we get an ellipse where the major axis is parallel to the x-axis. But if a squared is under the y minus k squared, then we get this ellipse where the major axis is parallel to the x-axis. And so that's the difference. And so to figure out whether it's this type of ellipse where the major axis is parallel to the y-axis, or it's the other type, which is the type where the major axis is parallel to the x-axis, we look at the numbers, these two numbers right here, and then look for the larger one. If the larger number is under the x minus h squared, and then it'd be the type where the major axis is parallel to the x-axis. But if the larger number is under the y minus k squared, and then the major axis will be like this one, is parallel to the y-axis. And now let's look at an example. So here we have the ellipse x squared dividing by 9, and then y squared divided y minus 4 squared dividing by 25. Now, if we want the equation to look like this, and then what we can do is modify it a little bit, where we can put in the x minus 0 squared. Now it looks like this form. And then first thing we do is look at the two denominators, and then look for the larger of the two. So 25 is larger than 9, and 25 is under the y minus k squared. Since the larger number is under the y minus k squared, the ellipse will be this type, where the major axis is parallel to the y-axis. And so that's how we know if it's major axis parallel to y-axis or major axis parallel to x-axis. And so we would use this set of formulas right here to find the center, the vertices, and the focus. And so when the ellipse is in standard form, the number that's with the x, that will be the h. And the number that's with the y, that will be the k. So in this case, we have h equal to 0, and then k equal to 4. Since we have x minus, y minus, and so we have x minus, y minus. And then the larger, the 25 and the 9, the larger one is 25, and the larger one will be the a squared. And then if we take the square root of both sides, we get a equal to 5. And then the smaller one will be b squared. B squared is 9. And again, if we take the square root of both sides, we get b to be 3. And then to calculate c, once more, c is the distance from the center to the focus. And to calculate c, we use this relationship right here. So we have b squared plus c squared is equal to a squared. So in this case, we get 9 plus c squared is equal to 25. And then subtract 9 from both sides, we get c squared is equal to 16. And then take the square root of both sides, we get c to be 4. And so the distance from the center to the focus, this is distance from center to a focus. And then A, this is distance from center to a vertex. Since we have two vertices, and then it just the distance from the center to one of the vertices. And so now we are ready to find the vertices and the foci. And so we have the center, which is H, K. And so in this case, we got 0, 4. And then the vertices, would be H, comma, K minus A, and then H, comma, K plus A. And then the second vertex is H. And the foci, so instead of A, it'd be C, because C is the distance from the center to the focus, from the center to the one of the to a focus. So this would be 0, and then comma 4 minus 4, which would be 0, 0. And the other focus will be H. So this would be 0, and then 4 plus 4, which is 0, comma 8. So the two vertices will be at 0, negative 1, and 0, 9. And then the two foci will be at 0, 0, and 0, 8. And this is what the ellipse looks like. So the equation is x squared divided by 9 plus y squared minus 4 squared plus 25 equal to 1. And this is the graph for the ellipse. And then we have the center at 0, 4, which is right here. And then the two vertices, they're at 0, negative 1, and 0, 9. And then the two foci, they're at 0, 0, and 0, 8.